Okay, I wanted to go and review the examples from the word problems that involve inequalities, and I wanted to again remind you of words that tell you greater than, less than, greater than or equal to, less than or equal to. So for that symbol, you would hear the words is greater than. Okay. For the less than symbol, is less than. And then for the, oh, that looks funny, doesn't it? Let's, how do I want to change that? Let's try this. Oops, sorry. Greater than symbol, less than symbol. Let's go to greater than or equal to. And we would hear phrases is at least. So it is minimally this, but it could be more, and is no less than. And I don't like this, so let me... Okay, and then the last one would be less than or equal to, would be phrases like is at most, and is no more than. Okay. So I'm going to go ahead and go to the next slide since I need some room to write these problems. Directions are all going to be the same. They're all going to say solve. And again, some of these require a little bit more, they're a little longer to give you background. So the first one talks about a bakery makes bread in which the ratio of whole wheat to white flour is 5:2. How much white flour is used in making a batch of bread containing at least 35 kilograms of flour. Okay. So what's interesting in this is it's using an idea back from chapter 3, which was the idea of ratios. So when you see that ratio of 5:2, it's not saying 5 exact kilograms of whole wheat flour were used to exactly 2 kilograms of white flour. If that's the case, then that would only be 7 kilograms. So what happens in a ratio, it's like a fraction, you reduce it to lowest terms before you talk about it. So in other words, I don't know how much white flour and how much wheat flour. So what I do is I add an x to each of the ratio values to represent the amount that was in there actually. Now, the order that the ratio is written in, 5 to 2, mirrors the order of the words of the object, so whole wheat to white flour. So that makes the 5x with the whole wheat flour amount, and the 2x to be the white flour amount. And coming up with our equation, we've got the 5x plus the 2x because we got to mix the two, and then we look for the word that tells us our operation. And in this case, it doesn't say is, which is our equals. It says the flour is used in making a batch of bread containing at least. So at least means it could equal that number 35 or it could be more. So at least translates to greater than or equal to. And then we have 35. And then we go ahead and simplify this and we get 7x is greater than or equal to 35. Divide by 7, we get x is greater than or equal to 5. Now the answer didn't ask me for what is x, what did I reduce by? It asks me for the amount of white flour. So I'm going to plug into that equation, and I get 2 times 5 is 10. So I need a starting point when it comes to inequality answers. Now, how I answer this is also a little different than regular problems, because there isn't one right answer. In fact, there's multitude of answers, because I'm not exactly sure how much flour is used altogether in that batch. I know minimally 35 kilograms, but it could be more. So how I answer is that there is at least 10 kilograms of white flour. Okay. Next, we have the sum of two consecutive integers. Is less than 75. Find the pair of integers with the greatest sum. Now this too goes back to chapter 3 where we talked about consecutive integers and how to define them. We talked about consecutive integers, consecutive even, and consecutive odd. Now they have patterns on how we define them. For consecutive integers, those are numbers that are one right after the other. So if x is the first number, x plus 1 would represent the second number. Now I'm told I'm going to sum them, so that means I'm going to add the x and the x plus 1. And then I look for the word that tells me the operation, or not the operation, but what symbol goes next. So I'm looking for a word that just means equals, but in this case it doesn't say equals, it says is less than. So that translates simply into the less than symbol. And then we're going to go ahead and combine up like terms. Oops, and I'm going to subtract 1 from both sides to get the constants on the other. And I get 2x is less than 74. Divide both sides by 2. And 2 goes into 7 3 times, which is 6 with 1 left over, and into 14 7 times. So what I'm looking for is an integer that's less than 37 to represent my x. So that means the biggest number I can choose is 36. And then its partner would be 37. So if you think about it, we have 36, and its partner would be 37. If I add them together, I get 73. That meets the criteria that the sum is less than 75. Now, the next integer under that would be 35, and the one higher than him would be 36. And we get 71. And if you notice, I'm going to keep getting smaller and smaller sums. So that says that that 36 and 37 is going to be the greatest possible sum. Okay, next one, number 3. We've got a student, and this one should be relevant to you, received grades of 83 and 95 on his first 2 tests. What grade must he get on his 3rd test to have an average of no less than 90. So basically the guy wants an A in the class. Okay, you know what? I'm going to take this percent symbol out because we actually don't need it on this. Okay, so this uses a concept that you've been using for years, and that's figuring out an average. And remember, an average is you add up all the numbers that you have, and then you are going to divide by how many numbers you added. So for us, that's going to tell us how to write our equation, is using that idea of average. The unknown is, what is the score on the 3rd test? Now, if you think about it, this is kind of a funny question because it doesn't matter what you calculate that you need, you still have to earn that grade. So to do an average, we're going to take his first 2 scores, add the 3rd score, divide by 3, and then we need to get to the inequality. So we look and it says no less than. So no less than goes with, it's minimally this, but it could be more. So that translates to greater than or equal to 90. Okay, now probably the best way to start this problem is to go ahead and multiply both sides by 3 to get rid of the denominator. And we get 83 plus 95 plus x is greater than or equal to 270. Adding up our like terms, we get 178 plus x, oops, that's supposed to say x, greater than or equal to 270. Subtract 178 from both sides, and we get x is greater than 292. So how we interpret this answer, greater than or equal to, how we interpret this answer is we say he needs at least 92 on the 3rd test. Okay, and that will get him his average that he's looking for. All right, let's try another problem. Now, some of the class, if you guys saw all 3 of those, and a couple classes only saw the first 2, so these next 2 nobody has seen. Bill is 6 years older than, than Nancy. Three years ago, he was at most twice as old as Nancy was. At least how old is Nancy? Okay, so if you remember, we dealt with this more in, chapter 8, dealing with age problems. So I'm going to do, we had a chart because we have two people at two different times, and we want to kind of keep track of that. So we've got Nancy and Bill are our two people. And we have two ages, age now and age 3 years ago. So now I'm going to let Nancy be N and Bill be B now. And then 3 years ago he was at most twice as old. So 3 years ago she would have been N minus 3 and he would have been B minus 3. So again, all this is I'm defining variables. Okay, so now what we're going to do is translate into equations. So the first sentence says Bill is, no inequality there. Bill is, that's his age now, 6 years older than Nancy. So switch a phrase. So basically we're going to do a little bit of substitution on these. And then 3 years ago says use the data from the 3 years ago column. He, so 3 years ago Bill was B minus 3, was at most, oh, now that changes things. So now we've got at most, so that means he could have been less than or equal to. Bill was at most twice as old as Nancy was. So Nancy, 3 years ago, was N minus 3. So to solve this, we're going to go ahead and take what Bill is now and substitute it into the other equation. So our equation is N plus 6 minus 3 is less than or equal to 2 times the quantity N minus 3. Now this makes sense because we want to solve for Nancy. So on the left, 6 take away 3 is 3. Distributing on the right, 2n minus 6. Subtract 2n from both sides to get the variables on the left. Subtract 3 to get the constants on the right. We get negative n is less than or equal to negative 9. And then we divide both sides by negative 1. And I draw that arrow to remind myself to flip the inequality. And I get n is greater than or equal to positive 9. So if I get a negative answer, I know I have something wrong. So remember, we just don't say she's 9. It asks at least how old is Nancy. So we say Nancy is at least 9 years old. I don't like how I wrote that, Nancy. Okay. All right, I got one more new one for you. This is the last one, going back to some integer problems. So the sum of 3 consecutive odd integers decreased by 15 is greater than twice the smallest integer. What are the 3 smallest such integers? Oh, let's do smallest such. Now the reason why they ask the question this way is because, again, I have an infinite group of 3 answers. But there's only one that would be the smallest of the integers that would allow me to do that. Okay, so again, we go back to chapter 3. How do we define 3 consecutive odd integers? Well, odd and even have the same pattern because in both cases they skip and they go to every other number. So to skip, we're counting by 2s. So x plus 2, x plus 4 would be our three numbers. So x represents the first number, x plus 2 is the second number, x plus 4 is the third number. And if you notice, they also talk about the smallest integers. So I'm going to refer to x as the smallest. Smaller would be if there's only 2. Okay? So the sum of 3 consecutive odd integers, that's easy. We're going to add the 3 numbers together, x plus 2 plus x plus 4. Decreased by minus 15 is greater than, so that's just a basic greater than symbol, twice the smallest integer. Well, x is the smallest, so twice x. So combining up like terms on the left, I have 3x plus 6 minus 15 is greater than 2x, which is 3x minus 9 is greater than 2x. I'm going to subtract 2x from both sides to get the variables on the left, add 9 to both sides to get the constants on the right, and I get x is greater than 9. Now remember what I'm looking for. I'm not just looking for consecutive numbers, but I'm looking for consecutive odd integers. I need a number that's an odd number that's greater than 9. Well, the first odd number that's greater than 9 would be 11, and that's the smallest possible value that is greater than 9, that's odd. So add 2 to that, add 4 to the original number, and that trio would meet the criteria being the 3 smallest integers such that x is greater than 9, the smallest one. All right, good luck with that.